Calculus kids, this is Dr. Callahan with week 16 Monday. How are you guys doing? Congratulations on completing week 15, so we're down to a brand new week. All right, so today we're going to go ahead and get started with the new free response question, and we're going to get started with this one right over here. It is your favorite, of course, on position function, velocity, and acceleration. So we're going to go over this question together. So hopefully it wouldn't be too difficult, but you guys are super smart group of kiddos, and I'm sure you'll do just fine. So take a moment and take a look at the 4 different parts and see how they're graded. Read the question because we're going to get started with this in a second. All right, so basically it says that, you do need to have a graphing calculator. Now, I did assign you guys a graphing calculator in class. If you have not grabbed a graphing calculator yet, make sure you come see me so I can assign one for you guys. They will not have graphing calculators on the day of the AP exam. They only have scientific calculators, which doesn't really do anything for you because you can't graph it. So make sure you have your graphing calculator. Make sure it's charged and ready to go. So from t equals 0 to 6, a particle is moving along the x-axis, and the particle's position and the particle position x of t is not explicitly given. The velocity for the particle is given by v of t 2 sine e to the t over 4 plus 1. The acceleration is given to you guys at a of t 1/2 e to the t over 4 cosine e to the t over 4, and x of 0 equals 2. So you're given 2 points, x equals 0, y equals 2. So A is the first part. And it's asking you, is the speed of the particle increasing or decreasing at t equals 5.5? So you want to go ahead and type this in for 5.5. Since it is talking about speed, you are looking at velocity. So essentially, we're looking at v of 5.5. So you can go ahead and just use your calculator for this. It's already given to you that this is speed. So you can just go to your TI84, go to graph, and then just plug it in. You can either graph this and y equals, and then type this entire thing into your graphing calculator. Then you take a second calc, x value, and you type in 5.5. And then you hit enter, and that should give you the answer. But your answer essentially for this question is going to be -0.453, and that is your speed. Then what you're going to do is you're going to take a look at the acceleration, because you need to obviously compare this to something. So your acceleration, you're also going to put that as 5.5. So you're going to put that 5.5 into this second equation, which is acceleration right here, okay? And you're going to go ahead and figure out what is your acceleration at t equals 5.5. So type that into your calculator. You should get a 1.359. So you're going to compare these two right here, and you can go ahead and say something like the speed is increasing at t equals 5.5 because v of 5.5 and a of 5.5 have the same sign, negative, and or you can put like negative 0.453 and negative 1.359. And that's something that you can go ahead and write down to justify your response. So looking at your answer here, it is worth 2 points because velocity and acceleration have the same sign with reason. Okay, let's go ahead and take a look at the second part, which is B. For B, it's just find the average velocity of the particle between the time 0 to 6. So if it's asking for the average velocity, What it's asking you is for the average value of the velocity function. Of the velocity function. And in order to do that, remember it's going to be similar to that of a slope. So on the bottom, remember the top is change in y, bottom is change in x. Well, your values here are going to be 0 and 6. So 6 minus 0 on the bottom. But then on the top, you're going to do the integration between 0 to 6 for the velocity. So then what you can do is on your TI84, make sure you go ahead and hit math. You're gonna go to 9 for the integration function. And then from there, you're gonna type in your velocity equation right here, okay? So you'll have something that has from integral 0 to 6, you'll plug this information right here in that box, and then dx, and then hit enter. So as you're putting this in there, just be careful with when you're looking at E, make sure you put the little caret so that you have a T divided by 4. Make sure these two are in parentheses so that way you don't have that messed up. And make sure you have the 1 on the outside with another parenthesis around the 2 in the sign, and make sure you put dx. And once you hit enter, using your graphing calculator, your answer for the numerator should be at 11.6963. 6 minus 0 is 6. And then, of course, when you go ahead and divide it, you should have 1.9. And this right here is the average velocity between 0 and 6. So this is how you would answer question B. So looking at the grading part right here, 1 point for integral, 1 point for the answer. So altogether, 2 points. Okay, so then for C, it says find the total distance traveled by the particle between 0 to 6. So for your total distance, you're looking at the absolute value of the velocity. So in this situation, it'll be the integral from 0 to 6, absolute value of v of t dt. So then you're going to, again, hit math 9 and have the integral boxes with the boxes. And then inside here, you're going to go ahead and type in, again, this piece right here. But make sure that when you're doing that, you're inserting absolute values on this. So let's just give this a try. So you're going to hit math, go down to number 9, and then you're going to put in 0, and then 6 for the upper bound, 0 for the lower bound, and then you're going to hit absolute value. And to get to the absolute value, you're going to go ahead and go to math, go over to numbers, which is the second row or second column, and then just go to number 1, which is ABS, and hit enter. And you should be able to see you have absolute value bars right there. And then you're going to take this piece right here, plug it in. So you're going to have 2 sine. To get to the E, remember you're going to have to push the second button and then go to the division button because E is on the back side of that. So you're going to put 2 sine E, and then make sure you put the caret so that you have the exponent, and then you're going to put T, or in this case X, divided by 4. And then make sure you put a +1 with this as well, but I will recommend that you put a set of parentheses around it before you put the +1. And then once you have the +1 here, parenthesis here, make sure you have the absolute value there, and then dx. And then hit enter. So I'm not sure about what your calculator is, but mine's thinking because it's a really big equation. And so your answer here should be 12.57362 12.531, or better yet, just 12.573. And this piece right here is going to be the total distance traveled. Okay, so for part C, again, 2 points, one for the integral, one for the answer. It's essentially just knowing how to use your calculator. Okay, for D, for t in between 0 and 6, the particle changes direction exactly once. Find the particle at that time. Okay, so some background information is it is only possible to turn directions when v of t is equal to 0. And v of t cannot be undefined. Okay, since we're looking at v of t, we're going to figure out when is v of t equal to 0. And you can go ahead and do this several ways. You can go ahead and do the y of 1. Make sure you put this equation right here. Hit graph and find it on your TI84. So let's go ahead and do that. So we're going to go ahead and graph the 2 sine, and then make sure you put the e caret t divided by, or x divided by 4. Close your parenthesis, close your parenthesis. Plus 1. And we'll go ahead and graph this. Okay, so what it's saying is, what is t equal to when y equals 0? So then when you look at your graph here, you can trace it over to that. And it's going to be something that looks like this. There's 1, 2, 3, 4. And then your graph essentially just kind of goes like this in between after 3 and dips over like that. So what you're looking at is you're looking at this point here. Which is going to be around approximately 5.19552. And you're able to find this if you actually just go to second calc. Going back to Algebra 2 Honors, you're going to go to 0. And then it's going to ask you like the left bound and the right bound. So the left bound, you want to put it right over here on the left side. Right bound, you want to put it right there on the right side. And it's going to make an estimate. And our estimate is that t equals 5.1552 when x equals, or excuse me, when y equals 0. Okay, so that's how you'll get that answer. So now that you know that v of t equals 0, so when t equals 5.19 seconds or minutes, whatever that is, you're going to go ahead and also look at the fact that it gives you x of 0 equal 2. So then what you're going to look for is going to look for x of 5.196 equals, when x is at 0, the initial position is at 2. So you're going to have 2 plus the integral of your velocity. And your velocity's lower bound's at 0, and the upper bound is going to be at 5.196. So then once again, using your calculator, you're going to go ahead and try to figure out what this piece is first. So we're going to go to second math, and then you're going to go to 9 for the integration. Or not second math, I apologize, just math, sorry, let's erase that, just math. 9 for the integration, I'm gonna put 0, upper bound is gonna be 5.196. Your v of t is gonna be that entire equation one more time, which is gonna be 2 sine, and again, if you don't wanna write the entire thing down, you guys are welcome to use the cursor to go up to highlight it in turquoise blue, select the equation you plugged in before, and then it just kind of brings it down. Make sure you type in 2 sine, then second division sign for the e, put the little caret on top for the x over 4, close your parenthesis, and then make sure you put a +1, and then dx. This piece right here should give you a 12.13477. Add it with a 2, and then your x of 5.196 is going to equal to 14.135 approximately. And that right here is the position of the particle at the time when it changes at 5.196 seconds. So here you can just put position of the particle. All right, guys, so the very last one, 3 points, 1 v of t integral, and then answer. All right, so then flip the paper over to the back. This is a second question on the 2013 AP Calculus for response question number 2. It's also on acceleration and velocity, and I basically have the grading right here. I have the responses from former students right here. And then also, if you need to watch the video, I have the video link with a QR code that you guys can watch as well. Okay, so the very last thing I want you guys to do is I want you to go to this link right here. Go ahead and read the responses or read the article on how to better prepare yourself for the AP Calculus test. There are 5 different suggestions: pacing, 2 system strategies, process of elimination, patterns and trends, and the right approach. And then what I want you guys to do is go ahead and just write down one thing that you took away under each of these 5 sections somewhere on your paper. Okay, guys, so after that, what I want you guys to do is go to your week 16 Monday free response questions in your white guided notes. So these are page 1, page 2, page 3, page 4. And you guys are welcome to go ahead and take a look at this. Oh, and then going back to the last free response question that we just went over together in class, I want you guys to go ahead and take a look at the intent of the question, like what was the purpose, why are they asking you that, and then take a look at the grade distribution for it. Okay, guys, I hope you have a wonderful week. As always, stay safe and healthy. Take care.